All right, last video of lesson 7.3. We're going to solve a problem involving similar triangles. Avery puts up a radio antenna tower in his yard. Ella tells him that their city has a law limiting towers to 50 feet in height. How can Avery use the lengths of his shadow and the shadow of the tower to show that his tower is within the limit without directly measuring it? So we can do this as long as these two triangles are similar, because then we can set up a proportion similar to what we did in our last example. So that's our first step, is determine if the triangles are similar. So first determine if the triangles are similar. So they gave us some pretty helpful information right here. They said that you can consider the angles at which the sun hits Avery and the tower to be the same. So what that means, they even marked it right here. That makes angle A congruent to angle R. So we've got angle A congruent to angle R. And then the other thing, they did put them in, but Avery is standing straight up with the ground, so we have a right angle. It's kind of hard to see. And then here we have another right angle. So those right angles will be congruent by our right angle theorem. So angle A is congruent to R, and angle C is congruent to angle T. So we have two congruent angles in these triangles, and that's enough for us to say the triangles are congruent with the angle-angle similarity. So triangle ABC, I just said congruent. The triangles are not congruent, they are similar. Triangle ABC is similar to triangle RST by our angle-angle similarity. All right, now that we know that the triangles are similar, we can use ratios of proportional sides to set up an equation. So now use ratios of proportional sides to set up an equation. So we can see that side AC is 5 feet long. So we're going to set side AC up over its corresponding side, which is going to be RT. So AC over RT, and then we can set that equal to, because we know that our triangles are similar, so all of these proportions will be the same. We're going to go, let's pick another side from the smaller triangle over here, because we started with AC, now we can say side BC over side ST. So that is the structure that we're going to follow to solve for what we're looking for. So AC is 5. We're just plugging things in. I look at RT, that is 40. Set that equal to BC is 6. And ST, that's what we don't know. We'll just go ahead and use an X just to make it easier to solve. That's side length X. Now let's cross multiply and solve. So I tend to multiply the cross product that has the X with it. So I'm going to multiply this together first. X times 5 is 5X. Remember, we set that equal to, we get out of the fractions. 6 times 40 is 240. We will solve for X by dividing both sides by 5. And we're getting X equal to 48. And remember, X was representing, we just substitute that in to represent ST in that triangle on the right. So side ST is equal to 48 feet. So what does that mean? What did we just figure out? Avery's tower is 48 feet high. Which is within the 50-foot limit. So So he is all good for the height of his tower.